So, good evening, everyone. My name is Scott Rodman. I'm a member of the Sea-Free and Green Energy Committees in Lincoln, Massachusetts. And we're here tonight with an event that's sponsored by Metro West Climate Solutions and co-sponsored by Green Newton and Sea-Free. And we're very excited to be talking about a topic that I think is a rather timely one right now, which is geothermal and network geothermal. And we are very, very pleased to have Angie Alberto Escobar here tonight, who's the Director of Gas Transitions for HEAT. HEAT started in 2008 as a nonprofit, stands for Home Energy Efficiency Team, and they have been instrumental in a whole range of projects over the years that have focused on drives to cut emissions, early solar programs, efforts on thermal imaging and blower door tests and so forth. But about the last 8 years, a good deal of their effort has been focused on dealing with natural gas issues and looking at leaks from the natural gas pipeline system and the delivery methods and so forth. And in the last couple of years, they have been very focused on these efforts for network geothermal, including the what I would call groundbreaking network geothermal system that is a pilot program in Framingham, Massachusetts. And so we're very pleased to have Angie here tonight to take us through some of the thoughts on what they've achieved and what the future looks like. And I'll turn it over to Angie. Thanks so very much for being here.
Thanks so much for having me. Good evening, everyone. As Scott said, HEAT is a 501c3 nonprofit, and I'd just like to quickly highlight that we don't take money from industry, gas, or geo in order to maintain our integrity, our financial integrity as an organization. We're funded by generous individuals and foundations and government, such as Mass Clean Energy Center, the Energy Foundation, a Pivot Prize, E for the Future, Cedar 2 Foundation, Bar Foundation, and a few others. So thanks for having me tonight. And I'm happy to share kind of the big picture of why gas to geo, and then some tangible actions that perhaps your community can take, but happy to answer any questions about the Framingham project or any of our work as well.
Can I also suggest, Angie, that, and to everyone, if you use the Q&A function, if you have questions during the presentation that you would like to see Angie answer at the end, please put them in the Q&A and we can queue them up at the end.
Excellent, thank you. So just to set the stage here, it's important to note that, our building stock, our current building stock is a huge source of emissions, and our current strategy for decarbonizing those building sector operations is to meet our heating and cooling needs with electric appliances, and having those electric appliances be supplied by renewable electricity. This is the dominant strategy in our in not just Massachusetts building electrification or beneficial electrification plans, but even beyond Massachusetts, New York, and other states, you see this as a dominant strategy. So it begs the question, at least for heat, what effect will this electrification have on our electric grid and on electric peaks in particular, which drive the cost of energy? So today we have a summer peak in the summer when most people's electric air conditioning appliances come on. But what will the peak look like when we shift our currently fossil fuel powered heating systems over to electricity? And so that's the question that HEAT started exploring. This is a staggering number, $2.5 trillion in the next 10 years just to upgrade or modernize our grid in the US. This reflects back in ratepayer energy bills, right? Like we are funding these investments in the electric grid. And so we see this as a staggering societal problem, the amount of investment required in order to meet folks' energy needs and what that will mean for people's everyday affordability, energy affordability. This report was published in December of 2023 by Oak Ridge National Lab. It showed that compared to the most popular technology for building electrification, air source heat pumps, when you compare a mass deployment strategy of air source heat pumps electrifying a vast majority of our building stock in the US, to ground source heat pumps serving the same function, you can actually save not just lots of infrastructure upgrades on our electric system on the transmission and distribution side, but that translates to real cost savings as well. If you go with a low operational energy technology like a ground source heat pump that has a significantly higher coefficient of performance. Um, so this study showed that it would cost 30% less to decarbonize the grid through individual ground source heat pumps, which is incredible and something to pay attention to. He commissioned a study um, to see what if we, snapped our fingers and electrified by different technologies, what that would do to our electric peak. And we call this the Falcon curve. When the wings of the Falcon are really high up, that means that the peak is incredibly high. That's the amount of electric grid infrastructure investments we would have to make because of that staggering peak that we have to satisfy. As you see, COP or coefficient of performance, essentially the efficiency of the technology increases. Air source heat pumps have a COP of 2, ground source heat pumps have a COP of 4. As that COP increases, that peak starts to lower, that the wings of the Falcon start to lower. A case study in Colorado um, gave us a COP for a networked geothermal system or um, a networked ground source heat pumps system with a COP around 6. And so that could decrease the amount of infrastructure and really minimize the amount of infrastructure that we need to build if this were the dominant technology being used to electrify our buildings. And so the message I really just want to drive home here is that efficiency of the technologies that we use, especially electric technologies, electric appliances, really does matter. Efficiency matters. Um, So at the same time, related to our work in methane, we and most climate advocates know that methane is an incredibly potent greenhouse gas. And um, in our state, this is the amount of infrastructure work that is required over the span of 5 years, from 2022 to 2027. This is a snapshot of the infrastructure work due to the leaky, aging gas system that exists in Massachusetts that is frankly just aging. We're aging out our infrastructure, and it's going to cost us by 2050 $1.4 trillion, according to a research economist, Dory Seavey, that ran the numbers. Um, And we know that these gas leaks, no matter how big the biggest, are the ones to target first. And that's some work that we've been doing. You can check out our gas leaks maps on our heat website. Those are the ones to target first, but really all of these leaks in aggregate are contributing to climate change. And we need to find a way to have plug and play solutions that can um, wean us off the gas system essentially so that we have less dependence and can minimize um, gas leaks in the future and minimize the amount of methane in the atmosphere. So as we're investing in our gas system by the millions of dollars, um, people are still electrifying. People are leaving the gas system actively. If you take a look at this figure on the right, uh, air source heat pumps have outsold gas furnaces and continue to outpace the sale of gas furnaces, which results in a house by house approach to electrification, right? What some folks may call an unmanaged electrification strategy. Don't know when people are making these decisions. They just are. They decide one day, or their current system um, ages out and they have to replace it, but there is no coordinated effort necessarily to this electrification. It's really a house by house approach. And the challenge here is who is left on the gas system with a decreasing rate base are likely folks that are renters and don't have a say on what type of heating system they have in their home, or um, are low-income folks that just, have to go with the cheapest option, or maybe just aren't informed about the options that exist for retrofitting a home to be electrified. So this is really a big challenge in our energy transition is ensuring that as we're transitioning it is equitable and we're not leaving folks behind in what we call the last grandma problem. So through these challenges that we've mapped out, uh, Heat engaged with many stakeholders on the challenges and came up with this possible solution. What if we use the right of way that the gas system currently has, um, use the uh, expertise of laying pipe in the street and simply change the energy transfer medium from gas to water. And so a geothermal network um, is very similar to the gas system. It has a pipe, a distribution pipe that runs down the right of way of the street, and service lines that go to each building. And kind of like the gas system, where you have a gas furnace in your home, you would have a heat pump in your home that is supplied the water from this distribution loop. And so this is what we call a geothermal network. It's a solution that came together over many charrettes, what we call community charrettes or stakeholder meetings, to help find a solution or a technology that can multi-solve for many of these societal problems that we're seeing. So this system is a closed loop system, so um, it doesn't have any contamination issues. Usually the energy transfer medium is plain water with some glycol or some antifreeze in it. The percentage changes depending on who is engineering the system and how comfortable they are with having minimal amounts of glycol, but it's very environmentally friendly material that is being used within the pipes, and it is a closed system. And this system would provide renewable heating and cooling and require a minimal amount of electricity. And so what Heat has proposed is in order to maintain a stable rate base and not leave folks behind? What if a gas utility with the expertise of putting pipe in the street, managing thermal energy, having that customer relationship already, that billing relationship with customers, and that long-standing trust of being able to supply them with their energy needs? What if those utilities were to install these systems and provide energy across an entire neighborhood, renewable thermal across an entire neighborhood at a time, no matter, the income level or whether they're renters or owners of the homes, but just provide thermal service down a cul-de-sac, let's say. So I'd wanted to clarify when I say geothermal network that folks aren't thinking of other geothermal technologies because this is very common kind of misconceptions. We're not talking about a deep geo district that um, uses hot water, brings it up to a central plant, and then distributes, the appropriate temperature around a hot water loop. Um, that is very common in Europe, Scandinavia, in places where they have really high heating loads. This makes a lot of sense, but there are a lot of efficiency losses all along the system when you're using that temperature. We're also not talking about geopower or geothermal for electricity, which goes even deeper and produces extremely high temperatures that turn a turbine to produce electricity. What we're talking about is closer to just an individual building with a geothermal system or a ground source heat pump at the building with some sort of geo exchange underground or in a pond, let's say, in their backyard. Um, we're talking closer to this technology, except um, the infrastructure is in a shared location along the distribution loop, and there is a distribution loop that is connecting buildings to each other. So this is considered shallow geothermal. It's only up to 1,500 feet around there is really the deepest that you'll go for a geothermal exchange system like this. And this does not provide electricity. Actually, you're using electricity at the building level, but it's highly efficient, and I'll tell you a little bit why. So this shared loop, people sometimes ask why even install this shared loop? Why not just do individual geothermal? Well, there's some interesting properties when you put in this shared loop that make the economics worth it. Um, when you target a location that has mixed energy use, there might be a building that even in the winter, because of its occupancy and say build machines in the building might actually still need to be cooled in the winter, and the ambient temperature loop can harness the waste heat from the heat pump. Essentially, as the heat pump is cooling the building, it can also reject heat or is pulling the heat out of the building and can place that heat into this ambient temperature loop, this shared loop. That shared loop that also has service lines to other buildings can now supply that now warmer temperature that's likely closer to the temperature that these buildings in the winter might want for their homes or their spaces, making the heat pump just work a lot more efficiently, minimizing the cost of energy for the folks on the loop. And if these folks were compensated for that waste heat, these folks could also be benefiting from this as well. With geothermal bores, these kind of vertical loops that are pictured here, um, in Massachusetts, we have great bedrock, which holds a lot of heat. And so we can actually store thermal energy across seasons as well. Say in the summer, we can dump our heat into the ground and pull it out in the winter. This is true over an annual scale, but it's also true over smaller time scales, which can allow you to store energy across the year as well. Think of the shoulder seasons. So, really, Heat has been exploring this technology and really advocating now for this technology because of its ability to multi-solve for meeting our emissions reductions targets in a neighborhood scale or block by block basis rather than a house by house basis, uh, increasing the speed at which we're able to meet these targets, but also because of the amazing electric grid impact of ground source heat pumps, as we saw with the Oak Ridge National Lab study. It's a great plug and play solution for avoiding investments in natural gas pipelines because they can deliver the exact same service, thermal service, but actually can now supply an additional thermal service, cooling, in the summer as well, expanding kind of the business model of the existing gas utility. Obviously, by reducing combustion in the homes, uh, health and safety could increase with the uh, decommissioning of gas, and for the reasons of equity that I mentioned. It's also local energy production, right? It's hyper local. You have the bores or your local thermal sources right around your neighborhood. That's the idea, is harnessing what is around us already for increased resilience so that we're not depending on, fuel that's being shipped from far away. And so I want to mention that this is kind of the progress to date. Um, there's a lot of utility interest across the nation. There is a quarterly utility network geothermal collaborative that meets to explore the topic that we're active participants in. Um, And the reason really that drove us towards the gas utility, besides obviously needing to solve for the gas system issue in Massachusetts, is because of an additional equity concern, which is a just transition for the gas workers currently. They are necessary, they are vital to steward us away from the gas system. There's so much institutional knowledge within the gas workforce that are actually out there repairing pipe, putting pipe down, um, that will be necessary in order to steward us into a clean energy future. And so being able to have a technology that can harness all of those skills, the pipes that are put in for geothermal systems today are made of out of HDPE, which is a material that is already used in the gas workforce today when they're repairing new pipe, putting new pipe in. They're usually using HDPE. So in the Framingham, Massachusetts pilot that happened recently, here's some photos from that. It was actually the gas workforce that was putting in that geothermal pipe. It was the same foreman that was, a week before working on a gas project. He was working on a geo project the following week. So it's pretty interesting um, how seamless it was in this pilot, the workforce transition piece. And really, Heat's work today lies in building out a project pipeline. So we've worked at the legislative level and are working within the regulatory space in Massachusetts and nationally, really, to set the enabling conditions for gas utilities to be able to do this work, decarbonize their business model on this large scale. But also, my organization recognizes that we need to set enabling conditions at the local level as well. And so here is a quick snapshot of um, a set of communities in the Commonwealth that received small amounts of funding but lots of technical assistance from HEAT in order to advance their exploration of this technology for their communities. And so, really, the goals here were to build visibility and inform siting in those locales, inform future siting. So, what does that mean? It means a lot of stakeholder assessments, really putting our ear to the ground to what people think about geothermal, informing them, educating them about the potential benefits if they were to, be a participant of a loop, etc. But also unlocking the local data like that exists at the local level already. There are already many neighborhood scale electrification pilots going on where people are being encouraged to decarbonize now. And that includes, maybe their gas stove, setting them up for success by upgrading their electric panels or doing weatherization early on. So um, we really wanted to share that information back to the state in a centralized way. And so collecting that information from those places, we've been able to share that now with folks on our website, which I'll get to in a second. But really, the idea is to inform utility and regulation policy that is being crafted really as we speak. Um, so here's an overview again of the awardees. We really kept it very broad in terms of who could apply. We wanted a diversity of applications, meaning the actual applications of the technology, who the end users would be. So we had life sciences buildings, a rural municipal campus out in Western Mass, affordable housing buildings, and an industrial campus even that did a feasibility study. But also we were able to achieve this amount of diversity in our applications of these feasibility studies because um, we left the door open for anybody to apply. It didn't have to be a municipality that applied. Sustainability organizations, faith leaders, and development corporations also applied. And really, this is a learning exercise. So um, I wanted to share that these reports are now available on our Heat library. And really that was the goal of this program, was to share out information about where communities truly are. And there are some that are incredibly ready and have gone really far into exploration. And I really encourage anybody that's interested in doing this for their own community to not just reach out to me, but to read through these reports because they're incredibly useful. So that's a little bit about the program, kind of where we are today. I do have some additional considerations for folks if we have time, but Scott, you tell me.
I think we do.
Okay, great. So I just wanted to share this QR code. If you have your phone in your hand, you can put yourself on the map. Part of the work that we're doing at Heat is really centralizing the interest. So what better way to do it than putting a map together? And so this really is to demonstrate interest in a particular community, in a particular municipality, and be able to connect people to each other if they want to be. None of the information is ever shared unless you give the okay. So I just want to state that. So for any one here that wants to think through what to look for in their community, I wanted to just share quickly one of the resources that we have on our Heat in our Heat toolkit, which can be found on our website. Let me just go back really quick and just highlight where it says learn more here, heat.org/gas to geo transition with dashes instead of spaces will take you to a toolkit with a number of resources, one of which is kind of a site selection criteria, if you will, a quick checklist of what you want to look for in a site. One of the first things that we talk about to communities is you really want to harness any opportunistic thermal resources if you have them nearby. What does this mean? Any buildings or facilities that might have a lot of waste heat that can be harnessed by a network geothermal system or a geothermal network. So think ice rinks, hospitals, breweries, even a data center can be used to heat some other buildings if it's close enough in proximity. And really, what you want in a site is density. You want diversity and density. And so, a lot of folks are interested in doing rural applications. It can be done, it will look a little bit differently. The economics really work best when you have urban density and some good load diversity, meaning that you have commercial buildings and also residential buildings all in the same place. For municipalities that are looking into this, or for coordinated municipalities, this slide is a little bit more. I think their language is how can you synergize with an existing project? If there's already some planned repaving work or underground utility work, why not synergize some project costs? Um, or target a neighborhood that already has either gas constraints and the economics will look good in comparison to the current energy rates that people are paying to ensure that people's energy burdens go down, um, or any high energy cost neighborhood that could be places with electric resistance heating or even oil-fired furnaces as well, or even targeting uh, a section of leak-prone pipe um, to um, to decommission if possible. I mentioned the um, electric resistance heating as a good opportunity to target. This is especially great if there are already electric capacity constraints in that area. You could free up some electric capacity by moving from a low COP technology to a high COP technology like a geothermal network. Um, there are also additional resources and considerations, but happy to move forward here and just share this opportunity. The Mass DEP currently has a wastewater energy recovery pilot grant program out. They are accepting applications on a rolling basis, essentially until they run out. And just wanted to share the opportunity because it is a unique opportunity um, that we're seeing right now that has multiple tiers of funding for this type of work. Wastewater energy is a great opportunistic thermal resource. You're recovering energy from a minimal amount of energy from an already existing waste stream, and um, you're able to lower the capital cost of a project when compared to geothermal boreholes because of the high cost of drilling. So this is a great program to go for if this is something that is of interest, and he is happy to support any applications that folks are interested in going after. So I will pause there and just say again that there are plenty of resources and many branches that we could go off into in conversation. I really welcome each and every one of you on the call today to reach out to me if you're interested in championing this technology in your community. Thanks.
Thanks, Angie. That was a big help. Uh, we have a couple of questions, but I'm going to start off with a couple of things here. Can you just discuss there's been a lot of question about geothermal versus ground source heat pump and understanding the wording there. Can you just take a minute on that? I think that's been asked by a couple people.
Yeah, sure. So, um, geothermal is like the last name of a family of technologies, all the technologies that I showed, right? And a ground source heat pump really refers to the appliance itself. The ground source heat pump is an appliance that is connected to some sort of closed loop water system that transfers energy into the home through a heat exchanger. And that um, ground source heat pump can be connected to various types of distribution systems, like a hydronic system in the home for heating or a forced air system. So that would be called a water to air or a water to water. Sorry, the other way around, water to water or water to air, respectively. So that is how I would describe the difference.
All right, thanks. Eric asked a question. I don't, Angie, you can pop them up and see the questions here so you can read as, but for people who are not looking at that, for the ORNL study, the text, this is from Eric. The text says 43% of commercial and 70%, 78% of residential. Is that CapEx or OPEX, OPEX, and of GSHP versus ASHP? Can you clarify that sentence?
Yeah, so this is for operational costs. So this is not considering the capital cost to install the infrastructure, and the percentages there are the percent penetration in that sector. So 40% of commercial buildings, air source heat pump or ground source heat pump, and 78% of residential buildings, um, either or of the
Okay.
technologies. Yes.
Thank you. And Janet asks, can gas pipes be cleaned and reused for thermal energy? I think you talked about that.
I think the gas pipes today are a different diameter than is required typically for a geothermal system because the energy density of gas is different to water. Um, but there may be recycling streams for that material.
And so where there high pressure systems versus low pressure systems, that makes a big difference as well, or in that reuse of anything.
I'm not sure about that. I would have to get back
Okay.
on that.
And one of the questions that's been asked over time has also been, how do you for the new development, how do you basically nudge the utility at this point? Are we at a point where the Framingham pilot is sufficiently proven that for a new development, the economics can be shown that that that's the right way to go for a new development of a certain number of homes, and is there a sort of a break point for the number that are needed to make it economically viable?
So those calculations are being done currently by a research team that Heat coordinates, the learning from the ground up research team that wraps around these utility pilots. And so they're actually breaking down the costs currently. Like there's an active project to break down the cost into more granular costs, but there's a functionalization and classification of the costs kind of exercise that is happening. And what that means is how can we compare these costs apples to apples with the gas system? So that's the exercise that's being done currently so that we can better understand um, what are the costs of starting a new utility versus what are the costs just to operate the utility itself. So
You mean put the utility in the ground for that new development? And by the way, can you also talk about the other? There's another pilot. There have been a couple pilots that have been discussed. Can you give us an idea where the status is on those?
sure. The other two that I showed was the Lowell pilot that was set forth and the Boston project that was set forth. That's in Dorchester, Franklin Field. So both are by National Grid. Um, the Lowell project was deemed canceled earlier this year, um, but there are um, community members that are looking to fund a potentially community-owned system. So there is still momentum in that area. It just might look a little bit differently than a utility pilot. Ultimately, the size of the project was too small to be economical in Lowell. For Boston, they're actually in the design phase currently.
Okay. And I think I failed to mention, I think you may have put it in one of the slides, that the Framingham pilot was 130 homes and then what, two municipal buildings? Well, part of one building and then the full fire station or something.
Yes, that's right. So there's a fire station and the auditorium from the school are both, yeah, are public buildings that are on the loop. There's also a gas station, funny enough, on the loop, and a number of residential homes, mostly multifamily.
Okay. Lisa asked the question, are mini splits geothermal?
So mini splits are the distribution system inside the home. So that is a mini split is what will distribute the temperature in your home. So that could go to an air source heat pump or it could go to a ground source heat pump.
And William asked, how do we get an idea of the capital cost involved versus the operational cost savings? I think what he's probably leading to is what's the payback period?
Yeah, that's a good question. It's what we'll hopefully be able to report after this exercise I was sharing with you in what we're calling the first gen report that Heat will publish by the end of this year. So January 1st, 2026, it should be available, if not sooner.
And there's also the report on Framingham as it's going along, the data after the first year. How widespread is or how has the analysis been done on that? Is that clear at this point for sort of a final product?
Yeah, I mean, there are multiple dimensions that are being looked at. And so for example, the electric demand dampening was not looked at in this first pilot, but a extension loop project will look at that closely. And that's important because it's important to quantify the electric grid benefit because that, can translate to real dollars. And so that is ongoing, I would say.
And that's the differential also between the electrical grid implications for an air source heat pump individually as opposed to a networked geothermal, correct?
Well, it wouldn't be comparative. It would just be the absolute value of what the change was.
I was leading into Jonathan. Hello, Jonathan. Jonathan's question: is there any cost data yet? We know that replacing gas pipe is extremely expensive. It is hard to believe that a community network GSHP system would be cheaper. Would it be much more economical to just do individual heat pump systems at each house?
Yeah, that's what we're trying to validate with the demonstration project data. That's exactly what the Learning from the Ground Up project is trying to answer. So sorry, don't have a answer for you today, but we will have a partial answer in the first gen report. Like I said, that's coming out this year, and a more complete answer after an extension loop project, which is hopefully happening soon.
And one question that I had here, the 1.3 trillion, I think it was, you said,
Mhm.
what area did that cover?
For the I think it was 1.4, and that was for the US.
1.4. That was US. Okay. Okay. Are there any other questions that anyone has at this point? I know I have lots of additional questions that I'm probably going to be bothering Angie with over the next months. I just had a house built that's using air source heat pumps with using air to air and air to water, two different systems, and I'm seriously considering the need that there really should be a home put in that has ground source as well as air source to compare data on a specific home and compare it on a degree day or some other basis because right now I think we're all flying blind on a lot of that.
Yeah, that type of example would be amazing. If anybody else wants to volunteer their home, uh, let Scott know.
Are there any other questions we have that anybody has for Angie tonight? No, everyone's shy tonight. Okay. Um, this is a fascinating topic, and I think that, I think the data when it comes out is going to be profoundly important for everyone to be able to see how this works. And I think to Jonathan's point and several others, the economics are. William asked the similar kind of question. The economics are going to be a crucial part of that, and seeing the results of this Framingham project are going to be fascinating for all of us to be able to digest.
Absolutely. And, we'll get it up to on our website as soon as we possibly can. But I encourage you to stay in contact and ask for updates.
So I think we'd love to have you come back when there's some data and actually just talk
Sure.
about that data and what you've learned. And can't thank you enough for all of your work and all of your colleagues at Heat, and Audrey Schulman, who is I regarded as the incredible leader who was there for a long time and is just did an amazing job of bringing that organization along. And so many of the people who I've seen do it working on the leak projects and other things from the community side. So can't thank you enough for all of the efforts here. It is truly a community effort, and it takes a village, as the saying goes, for all of this. So we thank you very much. And if anyone has any questions, please keep in touch with through Metro West or C Free or Green Newton. And the this video will be up online in the next few days. Everyone who's registered will receive a copy or a link to it, so you can be able to watch again and look at some of those charts and so forth. And if you didn't get the QR code, that'll be on there too as well. So thank you all very much, and have a good evening. And there'll be more to come.